Welcome back. Okay, in this module what we want to talk about is solving a linear equation that is a proportion. And we talked about the definition of proportion from elementary school. A proportion is an equation where on the left side you have one fraction and on the right side you have one fraction, and they equal each other. So if you look at your PowerPoint, I have the equation x over 10 equals 48 over 15. It is an equation, it has an equal sign. It is linear, it's x to the first power, which means we're going to get one solution. It is rational because it has fractions in it. But because it's one fraction on the left and one fraction on the right and they equal each other, we call this a proportion. Now I showed you in the previous module, to get rid of the fractions, you would use the LCD. But because this equation is so unique, it is called a proportion, there's another way to solve it to get rid of the fractions. And this is the method you learned in elementary and middle school. So I don't want you not to use something you've learned previously. Another way to solve a proportion is to cross multiply, which the technical name for that is called the cross products. Now, I want you to think about that. What does it mean when you said in elementary school to cross multiply? It meant to start at the numerator of the first fraction and to go diagonally across and multiply it to the denominator of the second fraction, and vice versa. Technically, that makes no sense because there is no multiplication symbol between the two fractions. Technically, that doesn't make sense because we're not asking you to multiply fractions. That expression does not say multiplying fractions is no problem, top times top, bottom times bottom. So there is no multiplication symbol in that equation right now. So when you use the cross product, when you cross multiply, that is a trick to get rid of the fractions without having to find the LCD. And it is a quicker trick because it's a lot easier for us to just cross multiply. So when I cross multiply, I start with the first numerator and I go diagonally to the denominator. So I'd say x times 15 and I'd write 15x. Then I put my equal sign and then I would crisscross the other way. I would take my other numerator, 48, and multiply it by the denominator to cross from 10. 48 times 10 is 480. So now my equation is 15x equals 480. Voila! There are no fractions. So what you may have missed out in elementary and middle school is the concept here. Cross multiplying, cross product is only used with a proportion. A proportion is an equation that has one fraction on the left, one fraction on the right. And it is a trick that gets rid of the fractions. That's all it does. Now that you have the equation 15x equals 480, we know how to solve that. We divide both sides by 15. We get x equals 32. So if you go back to the previous slide, when we solved the same equation by using the LCD of 30, we still got the same solution, 32. But I believe you and I can agree cross multiplying is a lot quicker and easier than trying to find an LCD. Here's the problem with tricks. You guys, once you learn a trick, you think it's great, but then you think you can use it for all examples, and you can't. The proportion, cross multiplying, is only used for solving proportions. A proportion is very specific. One fraction equals one fraction. So if you look at that equation I have on the PowerPoint, 5/8 x plus 1 equals x minus 1/6. You cannot use cross multiplying here. It is not a proportion. It is not on the left side just one fraction. There's a constant of 1. It is not on the right side just one fraction. There's a variable x. So because that equation is not a proportion, you would have to get rid of the fractions doing the LCD method. So in the scheme of things, to solve an equation that contains fraction, using the LCD will work for everyone. If your equation contains fractions and you use the LCD, you will always be able to solve that equation. However, if your equation is a proportion, you can solve it quicker by doing the cross product, cross multiplying. Let's try another example on the whiteboard.